What is use after freeboot? In this video, we're going to be exploiting UAF from Toddler's Bottle in pwnable.kr. It's only worth 8 points, so it shouldn't be that difficult. We're given a link to SSH2 for the challenge, so let's get started. First thing we want to do is, we notice that there are no files provided for us to download. So for easier analysis, we should get the files from this SSH. Well, if we try to do that, let's go ahead and SSH to this challenge. And upon examining the directory, we see we have two files that really pertain to the challenge. A C++ file, which we can actually cat real quick to see what it contains. Not very long. We see that it's mainly just these class definitions here. We have a human class, we have a man that extends human, and a woman that extends human. And the human actually has an interesting private method called give shell. This probably should be this probably is very useful for us. So this is probably what we're looking to execute. And in the main function, we see that we create a man and a woman, Jack and Jill, and then we run this loop. We have three options: use, after, and free. In the case of use, we just introduce the man and the woman. They have introductions here. And in the case of 2, we allocate some space in the heap, as you can see in this here. And then we read some data from a file into that area that we allocated. And the number of bytes that we read into it depends on what we specify as argv1, and the file that it reads from depends on what we specify in argv2, which are really the first and second parameters to the function, or to the C, or to the binary. And in the case of 3, we delete the N and W objects, but really these are frees. Same thing. So we can already from this C++ see the problem here, because if we use 1, if we select 1 after selecting 3, the M and W pointers are still pointing to what used to be the locations for those objects on the heap, but those locations may have been overwritten by some other operation that needed to use that area. For example, in case 2, we are allocating a string, essentially a string on the heap, and if we free, then allocate a string on the heap, and then execute this, then we can actually control what is executed just by supplying this this case 2 here, or supplying the arguments to the function. So for analysis, for further analysis, we should give the binary a disassemble. So what we can do now is actually use secure copy to copy this. Ooh, what's going on here? Okay, to copy this into our local directory for analysis. So let's go ahead, and I don't actually want to log out of here. Maybe I can use this. I think, so. Okay, let's secure copy from UAF at pwnable.kr, and the file is UAF, just to the local directory. And when you use SCP, it works pretty much the same way as SSH. It just will copy the file, and to verify that it's there, you can just do a quick listing, and we see that UAF is indeed here. In the directory. Okay, so now that UAF is here, we can use stuff like IDA Pro to analyze it. And here we have it. Looks pretty complicated. This is the main function, but really most of the functionality is here in terms of the switch that we have from the menu options. So we see that if it's 2, we execute this big block here. If it's 3, we go down this path here. And if it's 1, we go simply to this block here. So it's not so complicated. And then this all loops around. So we have multiple options to use after and free. So taking a look at 2 here, we see that first we have a this conversion that we already saw, the A to I, so it converts that to an integer to determine the size. And then we have this allocation here, and this occurs on the heap, and it takes in whatever, not exactly sure the exact mechanism for this, but whatever is most recently freed probably should be allocated by this first, and I don't know what I just did, but okay. And then over down here we have an open of the file that is specified in the second command line argument, and then we have a read of that file into the pointer specified here, which is actually pointing into the heap because that was returned by this new operation there. Then we just get some prints, new data is allocated, blah blah blah, and that's it for that. In the case of free or the delete operations, it's pretty simple. All we do is essentially call the operator delete, and it looks like here that we delete both of the declared humans because we have 2 of them here, and we also have these 2 pointers, RBP plus var30 and RBP plus var38, that probably also correspond to the two objects, the 2 humans. In the case of introduce, option 1, we have a loading of 38 and an offset of 8, and then calling that, and then same with 30. So pretty straightforward there. Okay, so how will we get this to execute the shell that we were looking at earlier? To find out, let's go ahead and go into GDB. So it's GDB UAF, and for simplicity, let's put breakpoints at each of the 3 options. So the first option is located at here, the main block of code at least. It's 400 FCD, so break at 400 FCD. The second option is for the deletes or the frees, and they are at 401076. And the last one is down here at 401000. So, okay, now let's give it a run. And let's go to use first to see what's going on. So we see we have a movement of this into RAX. Let's take a look at what is there. So since this is a 64-bit binary, we should use 2 words when we analyze address pointers. So in this case, we want RBP minus hex 38. And we see we have this. This is probably a heap address, and same goes for 30, which we saw earlier down here, just later on. So we can give these 2 locations a look. So 1A5, FEA0 for the first case. Oh, bad. Examine 8. And this looks like something in the code segment. Actually, not sure. This could probably be. So let's go ahead. And so this is actually another pointer. So the heap contains a pointer to a pointer here. And this pointer, let's look if we can get any sense out of this. Oh, actually, this is the give shell. And actually, we can see that up here as well, including the pointer pathway here. So this is the address that we want to go to, and to do that, we have to edit the heap entry here so that it will actually point to here. But if we look at the binary here, or the disassembly, we see that after we load in that 40, this number here, we add 8 to it before calling, before dereferencing and calling. So let's try adding 8 here and see what happens. We should be getting the introduction function pointer. Okay, so let's look at what we have. Okay, so this is exactly what we expected. We have the introduction when we add 8 to the pointer to the pointer of the pointer, the pointer of the Okay, so our goal is to overwrite this with something that when added 8 gives the actual value. So all we have to do is subtract 8 from here, let's see, give shell. Yeah, from here. So we need 8 less than this written into this location, which right now currently holds 8 more than that. So let's make a note of this. And so, okay, need to overwrite with hex 401568. So this is key. So how will we do this? Well, if we go back into the disassembly, we see that it essentially just reads in the bytes. It just copies the bytes into a newly allocated space on the buffer, or not the buffer, the heap. So we're not exactly sure if this will write to a freed man and woman pointer, but since those were the last free pointers, it wouldn't be unreasonable in any way. So what we can do is go ahead and create a test here. So let's go ahead and print, let's just go ahead and print that actually, that address. Just pad it up with some extras. So 681540. Okay, this should be good. And we're going to print that into a file. Let's call it UAF text. And anytime that you want to analyze the actual contents of such, you have such bytes here that can't really be displayed, you can always use the convenient hex dump. And we can see that we've successfully printed it out here. Let's go back into the UAF and set breakpoints at the 3 locations again, which I believe we can just use like this. Okay. And let's give it a run. Actually, what we want to do is give it a run with 8 bytes, following the conventions that were specified in there, like this. So first thing we should do is go ahead and give it a free. First thing we do is free, and we can analyze what happens to these variables as we free it. So RBP minus hex 38, we'll keep an eye on this and the memory location that it contains, or the heap contents. 880. Okay, so right now it holds that address that we were looking at before. But let's free and see if anything happens to it. So, okay, let's give it a look now. Ooh, it's been zeroed out. It's been zeroed out. So after the free, if we don't write something valid to this, it will actually probably give a seg fault. Yeah, so let's continue. And this is going to basically destroy the other human as well. And, okay. Okay, so we're back here. Let's just continue. And we already see we have the menu up here. So let's do after now and see what happens. So first, we have an A to I, and it looks like we got 8, which is what we expected. And then we have this call to underscore z nam, and this is essentially the new operator that we saw in the C++ here. Let's go back and continue on. Should have some space in the stack. Now actually, before I wanted to look at what this address was. It's 12dbef0. Was that the same as the one that we had up here? Not exactly sure, but we'll take a look after. So let's just keep stepping. And then we have an open, and then we have a call to read. Okay. So let's go ahead and take a look at what this contains now. 12 dbef0. Okay, great. So the address got successfully written into wherever this was allocated. So this was successful, but we don't know if this was actually the pointed to by any of the human objects. But we can always check. So we checked 38 before, and it wasn't that. I don't think it was that. 12dbea0. Ooh, so we're off here. What about for 30? Aha, 30 matches it exactly. So we actually overrode it for, I believe that is the woman, Jill. We overrode it for Jill, but Jax is still not. We can confirm this by just, yeah, it's still zeroed out, so we haven't copied it. But if we do it again, if we allocate this again, we might be able to overwrite Jax as well. So let's give it a run. Just continue here. Past the read. And oh, I meant to look at the pointer there, but since we don't have it, that's fine. I believe we can look at it somewhere else. Okay, yeah, we have a buffer here, RBP plus buff. Buff is located at EBP minus 20. So examine 2 words at EBP minus x20. Oh, not EBP, RBP. 12dBEA0. This was indeed what we were looking for Jack. And now that we've read it, we should be able to see it. Great. So we've overwritten the address for Jack and as well as for Jill. Yep. So you can see both of these 8 bytes are the same. So now let's go ahead and go to use. So use, we shouldn't be surprised because we've already looked at this. We add rex to point to 8, so now it points to the shell, and then we dereference that, move that into our dx, so our dx now contains this address, and pretty soon we're going to be calling it, oops, new program, bin dash. Great, so we've gotten the shell. So this is exactly what we need to do on the other machine. So let's go ahead and head over there. So this is the actual SSH area. So let's go ahead and create something. Oops, didn't mean to do that. Okay, so let's just go to the temporary folder and okay, so we need to do the same kind of thing here. So I forgot it was 68. All right, let's print it out, and we'll print it into UAF text. And okay, now let's go back to home, and let's run UAF. With eight UAF text, which comes from temp. So first free, then overwrite Jill's, and use. And we got a shell. Nice. Who am I? We are, UAF. So now we can have access to flag. And I'm kind of interested to see what this says. Yay, flag after pwning. Okay, kind of anticlimactic there. But now that we have it, we can go ahead and go and verify it. And we have login first, and that is okay. But we got the flag, and honestly, that was kind of an interesting challenge. It was quite extensive, I think, for 8 points. But again, it was very interesting, and the exploit worked kind of nicely. There wasn't any special circumstances we had to watch out for, besides just making sure to overwrite twice. So thank you very much for watching. I hope you enjoyed, and I'll see you in the next video.